Students, today we're going to see about interrupt controller. So what is interrupt controller? Interrupt controller is a programmable peripheral that manages the interrupt request from the hardware or other peripherals to the CPU. Okay. So the interrupt controller is your A257, Intel A257, and the processor that stands evolved with the interrupt controller to reduce the burden of the CPU. So this interrupt controller is particularly programmed to reduce the burden of the CPU, and the interrupt controller is a programmable peripherals that enables and disables the interrupt request and selects the interrupt priority. As the CPU has limited hardware lines and computing, and the interrupt controller extends the CPU for multiple interrupt by multiplexing interrupt with interrupt from peripherals. Okay, and this is your 8086 architecture, and by this diagram you can clearly understand how interrupts are connected with the processor. So here we're going to see the example of Intel 8259 is a programmable interrupt controller. There are 5 hardware interrupts and 2 hardware interrupts in A2 in Intel 8085 or 8086. Where we take the example of 8086. It has 2 hardware interrupts, and by connecting Intel 8259 with this microprocessor, we can increase their interrupt handling capability. And in Intel 8259 combines the multiple interrupt input sources into a single interrupt output. So interfacing a single PIC provides an 8 interrupt inputs, that is from I or not to I or 7. For example, interfacing an 8085 or 8086 controller with 8259 increase the interrupt handling capability of 8086 microprocessor or 8085 microprocessor from 5 to 8 interrupt levels. Okay, and next slide is that. Let us see what is programmable interrupt controller. So as we explained earlier, this IC is designed specially for implementing the interrupt interface to 8085 or 8086 based microcomputers, and this device is known as programmable interrupt controller or PIC, and it is manufactured by NMOS technology, and it has 28 pin dual batteries, and the operation of PIC is programmable under software control, and it can be configured for a wide variety of applications. 8259A is treated as a peripheral in microcomputer system, and 8259 PIC adds 8 vectored priority encoded interrupts to the microprocessor. And this controller can be expanded with additional hardware to accept up to 64 interrupt request input, and some of its programmable features, that is Intel 8259 is designed for 8085 and 8086 processor. It can be programmed either level triggered or an edge triggered input level. We can mask individual bits of an interrupt request register. We can also increase the interrupt handling capability up to 64 interrupt level by cascading further 8259 PIC, and the clock cycle is not required for this 8259. And this is a pin diagram of 8259. Here we can see through about there are totally 28 pins in 8259, where VCC is 5-volt power supply and ground, and other pins are D7 to D0. So D7 to D0 is for the communication with the microprocessor. There is a 8 bidirectional data pins. Okay, next is a RD. RD is an active low input pin that activated by the processor to read the information status from 8259. And next is your write, that is your WR. It is active low input pin which is activated by the processor to write the control information to the 8259. Next is your chip select. So for selecting the chip, it is to be actively low input pin. And next is your A0. So A0 is your, in here is that it is an address input pin used along with the read and write, which is used to identify the various command words. And here IR0 to IR7, these are 8 asynchronous input request interrupt request inputs, and these interrupt requests can be programmed by using level triggered or edge trigger mode. Next is your INT. INT is something a strong active high output pin which interrupts the processor, and it is always connected to INTR input of 8085 or 8086. The INT input is only activate when all the given conditions are satisfied correctly. So this is the pin diagram of 8259, and moreover INTA is termed as an active low input. So the 8259 receives a signal from INTA to the output of 8085 or 8086, and it sends 3 consecutive ITA signals. So that is said to be a 3-byte call instructions via D7 to D0 pin. And next is your CAS to CAS0. So these are cascaded line used only when there is a multiple 8259 in the system, and the interrupt control system might have master 8259 and 8 slave 8259, and SP and EN. SP stand for slave program and EN stand for enable buffer. This pin serves as a dual function. When it is used as an EN pin, it provides an active low output pin that controls the buffer transceiver in the buffer mode. So this is a so here we have highlighted that IR0 to IR7 using a 8 hardware interrupt device are supported. So in this pin diagram clearly see about it. And next these things have been explained, and so when 8259 is in buffer mode, and this pin is an output that controls the data bus transfers in the large microprocessor based system. When the 8259 is not in the buffer mode, this pin programs the device as a master 1 and slave 0, and CAS2 and CAS0 is a cascade lines which I have explained earlier. In next class we will see about the block diagram of 8259. Thank you. If you have any clarification related to this topic, kindly communicate to me. Thank you.